So I'll pick up where Chris left off. And again, realize we are using a ignition designer here, but nothing that I'm going to show you is ignition specific. It's all MQTT spark plug B specific. So this is that tag provider that Chris showed you. And in that, I've got this notion of a unified namespace where I've got Smart Factory 1, laser lathe, and then you can see I've got a instance of the model that Chris created. So I have an instance of a generic CNC fan-up controller that was built from the model that Chris did. And I've also got another one that we worked on previously, my famous Acme laser lathe. So the advantage we've got here, as Chris said, is that with ignition UDTs, we get to build up the models, and then we can use inheritance and put those in a hierarchy. So Schwab and Chris and Will and everybody basically created these models that were generic in that now we can start using those from the MTConnect definition. So the intent here is that these would be well-defined models that everybody then could use up here. So in here, Chris has created components that will be used by his fan-up controller, but you can see they're inherited from the MTConnect definitions. So now if we go into the UDT for the laser lathe or for the CNC, we can see here that this controller is a parent type of the MTConnect definition / device. And then as Chris went through that, the axes are, inherited from the FANUC, which again are inherited from the MTConnect definition. So that lets us go in here and, if you will, we can prototype where we want to finally get to in the final MTConnect definition of the model. So as Chris has been doing, we can iterate, we can go, that doesn't look quite right. Let's go back to the MTConnect definition, change that, then we'll pull up that new definition and reuse it up here as we start to go through some of the model definitions. So here we've got our hierarchy all the way down as Chris had mentioned, down to the observation. Now, what that lets me do is now that I've created the model, I can go and use the model and create my lathe and all the parameters here. And so for all of the UDTs, for all of the models, if you will, the parameter section is what is unique. So I've got this notion of an Acme laser lathe, and uniquely, what we're targeting here is the machine builder. They're going to put this agent on. They're going to know what their machine does. And so most of the parameters would be taken from that machine. So, here it would pick up the name from that machine, the native name, the sample interval. All of this would be data from the machine. So think of these tags not as ignition tags. Think of these as the agent that knows about the MTConnect definitions, that then it can utilize those and start creating models that it can start publishing. So at that point, we get to basically, again, experiment. So this is my MTConnect folder, and it contains my machines that are going to be publishing MTConnect data to an MQTT broker. So if I pull up a topology diagram, this could be my factory. I could have 1 or 100 CNCs or laser lathes, and they would all be publishing to an MQTT broker, where, using Sparkplug B, where another MQTT client is listening to those publishes. So again, the advantage here is that, auto discovery plug and play is that if I'm following the spark plug specification, I should be able to take whatever Chris, Sharab, myself, Will are putting together and actually be able to properly represent that. So I'm going to do that right here, actually within the ignition. So I've got, let's pretend this MTConnect tag provider, that's a factory floor, it's not ignition, and it's got a FANUC CNC, and it's got my Acme laser lathe. And now I'm going to go over across the world to another location where I've got another MQTT client running, MQTT engine. And right now, I do demos all the time. So I've got some Opto22 equipment. I've got some Emerson Rock devices publishing in, but I don't have this notion of my smart factory. So what I'm going to do, and also over here, notice that I've got some models, if you will, UDTs that came from this other equipment, but I want to add my laser lathes. So what I'm going to do is I'm going to go in to my ignition, and I've got my transmitter set up, and I'm saying MTConnect, go into MTConnect, pick up all of the data and the models and publish those to a default broker. And then what I'm going to do is once I've got that set up, I'm going to enable that right now. And boom, all of a sudden, I've got my Smart Factory 1, laser lathes, new FANUC, and those, I didn't know about those 2 seconds ago. And we were able to, using that birth certificate that Chris mentioned, we actually published all of the MTConnect, our baseline models. Then we published the UDT for the FANUC controller. So literally without me having to write a single line of code, without doing anything, I was able to auto discover these very complex machines, and they automatically showed up with all the parameters and all of the real-time data report by exception coming in. And we're working on this right now. We're going to do a Sparkplug data dash with at ICC and have all of this information be learned automatically across many, many different locations around the globe. Now, if we take that to the next level, which I think, ultimately we all got to start thinking about this, is that, okay, I just published some models from my machines and I learned those in a client. Okay, ignition's there. I mean, I know Aviva's doing this. I know Rockwell's looking at this. So a MQTT Sparkplug compliant client is listening for those models. Now, over here, we could look at that the same way, is that we also have digital twin capabilities with Azure Digital Twin, SiteWise, and Snowflake. So we could have another agent that is Sparkplug aware that could be listening for those models as well. So we are in the process of putting this together. But if I go back into another tag provider here, into, let's say, my Smart Factory, and in my Smart Factory, I've done the same thing. Now, these are my models of what I think an extruder might look like, what a chiller might look like on a rooftop unit with a model of a compressor and a cooler combined with that. But I've got this notion of these models coming from my Smart Factory. And again, we're using the same kind of unified namespace. I can go down to line 7 and see that I've got an extruder that's using the extruder model and all of its parameters as well. So, from a modeling standpoint, with any modern system, that gives me the ability to build templates. And then those templates we can start putting together from a visualization standpoint, or anomaly detection, or machine learning and start realizing this data coming in real time. And then once I've got this, it's this notion of on August 31st at 10:31 a.m., this is my single source of truth. This is my factory. I know I'm right there at the edge. And in fact, again, following the goal of MTConnect, the extruder is publishing this directly from it. It's coming out Sparkplug B. And now we want to take that and we want to get it maybe into a service like Snowflake. So if we look at maybe a Snowflake console, we have this notion of, again, viewing that using Sparkplug B and actually have a view that we might be able to go out and query what our machine models look like. But again, we don't know anything about the smart factory, so we'll go back into Ignition and we'll go to our transmitters, and we're going to, just like we enabled MTConnect, we're going to enable Smart Factory, but it's going to publish to a different MQTT broker. It's going to connect to the one that's connected to Snowflake and start publishing that birth information. So I'm going to go in and edit this and enable it. Save the changes. Now, the same thing happened as what happened from the machine. So from the machine, it established a secure TLS connection, no ports open into the machine, to probably an on-prem MQTT server. Then we built the models in Ignition. Now we've got another MQTT agent that knows Sparkplug that can pick up those models, publish them again, where we have an IoT bridge listening, knowing, oh, I just got some birth messages, so I will build those out in my Snowflake digital twin. I hate the word, but I'll use it for this context. And now if I go back and look in refresh my view here, I've got that entire smart factory. And because I'm using Sparkplug, now I've got views of all the machines, and I can go back and query for the birth messages that had the models in them. And lo and behold, I've got an extruder model. I know what that is. So that lets me go, again, all of this data is flowing into a single SQL database, but I can do a query based on my knowledge now that I've got Smart Factory 1, line 7. It's an extruder device, and then be able to populate all of my columns with real-time process variable using sub-millisecond insert into Snowflake. And again, we've got, you could look at that with Azure Digital Twin and AWS SiteWise as well. So from my standpoint, it's very exciting to see, we have customers that are building models all over the place, but to have that standardized, the model standardized, going over an open source representation, Sparkplug, being able to flow that into the factory, and then taking those same models, made that same source of truth, and being able to flow that onto the cloud. So I will stop right there and see if there are any questions.
Thanks, Arlen. If anybody has any questions, put them in the chat or just jump in and unmute yourself. I'm also going to ask the same question I asked Chris. Arlen, so what's coming next? What do you have in mind for where this needs to develop towards?
Well, I'm getting industry feedback. Again, I think our first like public debut, if you will, is that Inductive Automation are having a Sparkplug Data Dash challenge for their ICC show at the end of September. And they have sent out a public challenge to all the integrators, to all the OEM device manufacturers, to anybody that's doing MQTT spark plug. And they have set up an MQTT broker for everybody to connect into. And that'll be distributors in Australia and France and Germany, Australia, Brazil, and all that data will be coming in. And then we're going to learn those models. And one of the participants is we're going to use this this ignition gateway. We're going to publish the models that Chris has come up with, and those are going to flow in as well. And during my discussions with the audience there at ICC, we're going to say, hey, not only are we publishing this data MQTT spark plug, the model inside of the spark plug metrics, if you will, is derived from this definition from MTConnect Institute. And a lot of the customers there will know about MTConnect, and maybe some of them will actually learn about it. So that's kind of my next steps.
Yeah, I mean, some of the principles that go into sort of closing the loop from Arlen, before you jumped on, one of the folks that was working on precursors to MTConnect from the late 90s. The idea of modeling something in a standardized language that's consumable by a computer, the whole intent of that was to make it so that there was this eventual proliferation of other tools and other systems talking to systems, and that took longer for some of it than I think anybody had anticipated. But to see the on-ramp for sort of the ignition community to come to MTConnect, which is a pretty specific domain model, but that would really not be feasible without having put the model together in SysML in the first place. So having it model based and having the pipeline between the MTConnect SysML model to help define the spark plug, which of course is dependent on MQTT, that whole stack of things is what has been evolving. And I think that's where your enthusiasm, at least when you got involved with the MTConnect side of stuff, you seemed super, super fired up about all that. And I share your enthusiasm. I know you can tell from my voice how enthusiastic I sound, but it feels like things are actually different this time.
They really are. And from my standpoint, I've been doing this for 47 years, and, I've been everywhere from, I was on the Heart Foundation board of directors for 8 years. I fought all the field bus wars, and we're still really no closer in having machines that just, we got stuck with protocols, and we got stuck so hard that we're having a hard time getting our head kind of like wrapped around the fact that if I have a $100,000 lathe and it goes in, it's probably got the intelligence to tell me what the heck it is and what it's going to do and how it's going to do it. And I shouldn't have to read a manual and figure out 5,000 different registers and which ones I want to pull and how often.
Amen.
Even the basic concept that you would have a machine that is self-describing, which is sort of shorthand for that description you just gave. That idea of a self-describing machine is a largely a computer science concept. And there's still, I mean, I'm not going to speak for all manufacturing, but certainly inside discrete and inside machine tools, where I've spent most of my career, it is still somewhat rare to find people that are thinking in those terms about their, ironically, computer controlled equipment. So bringing the concepts and approaches and I think the expectations of how the equipment ought to be behaving and how it ought to be behaving more like a computer was something of a prerequisite. And it's a small-ish space compared to mainstream computing. So that's one of the reasons it takes so long for the stuff that seems obvious if you're coming at this from a software developer perspective, why it takes so long for it to show up in industry.
Right. But I mean, we all have to realize, and I do, Russ, I do a lot of keynotes and I go talk at colleges and stuff. And one of the notions is that we kind of got stuck because remember in the late 1970s, 1980s, we had this thing called RS-232, and that by its very nature had to be pole response. So, I understand where it came from, but that was 1980, right? It wasn't 2023. And, I think that TCP/IP has matured. The technology has matured to the point where we've got open source, very available things like MQTT, like Sparkplug, like MTConnect, that we can start putting those together and actually start making some progress in this, to where, I still remember Carl Voss was the IoT executive at TE Connectivity, and they make connectors. And he said, Arlen, I should be able to walk into my factory and with proper permissions, plug my laptop in and learn my factory in a few seconds. And that's why that always stuck with me, is that, yeah, I should be able to plug in and all of a sudden my factory's commissioned, because all my equipment told me where it was and what it was going to do, and then keeps publishing all of its data report by exception.
What year was that?
That was probably 7 years ago.
Okay, yeah, that's good. That's what everybody should be expecting.
Yep.
All right, thanks
Hey,
so much to Arlen.
Oh.
More questions from the. Oh, go ahead, Jan. Sorry, I didn't mean to cut you
Yeah,
off.
sorry, Jan here from Lockheed. Hey, yes, Arlen, I got a question. Can you give your opinion about where does OPC UA fit or not fit in this whole concept? So now where it does, is there a spot, because I don't see it here, in everything there's of course the MTConnect, but is OPC UA something that fits in this as well?
Well, Jan, I don't want to. I never try to get into an OPC versus MQTT discussion. I think they're both have their strengths and benefits. OPC, as far as a on-prem polling, you gotta open ports. You've got to be able to go out there. You got to find those OPC UA registers. You got to get them configured. And it's so complex. One of the things that I will note is that if you take the MQTT spec and the Sparkplug spec and you smash them together, I think it's still less than 200 pages. And when you get into thousands of pages of a spec, it's really hard to validate and implement that, if you will.
Yeah.
So, for things like on factory and closed loop control and, polling machine PLCs, I don't think in the near term that's going to go away. But I will say that when it gets to the point where a machine now has the ability to publish its information using a well-known protocol, and if we've got all of the semantics right within Sparkplug, and again, remember, MQTT was designed for Phillips 66. Andy and I invented it in 1999, and it was for a mission critical command and control. That's why it has death certificates. That's why it has all of those things built in that sometimes people don't understand. But I think going forward, it's a very viable alternative to OPC, but it's never going to replace it. They're both going to be around for a very, very long time.
Mm-hmm.
And truth be told, Jan, is that I would say that 85-90% of where Cirrus Link modules are used are in a system where the OPC UA client is being used in Ignition to get the raw OPC register values that then goes into Ignition, where then we pick those up with our MQTT modules and publish those OPC registers that we got using OPC via MQTT Sparkplug.
Right, and then you can change it again to an MTConnect model, right?
Right. Yep. And that's what we're getting to.
Right. So it's not, it's not as if OPC UA doesn't fit in this architecture. It could, but still, then you would at the back end, you'd still get an MTConnect model.
Yep.
Okay.
That's correct. And that's the really, Jan, from my standpoint, that's kind of what I'm excited about with the Sparkplug Data Dash, because once we get the MTConnect models up on the Ignition Exchange,
yeah,
then that means anybody could go grab these and create their own MTConnect machines.
Mm-hmm. Yep, and hopefully publish them too.
Yep.